Hey everyone, welcome back. Today we're exploring one of the most important concepts in C++ programming, arrays and vectors. These data structures are the backbone of storing and managing collections of data in C++. Whether you're building a simple program or developing a complex application, understanding how arrays and vectors work, their features, and how to use them effectively will take your programming skills to the next level. Let's start by discussing arrays in detail. Arrays are a collection of elements of the same type stored in continuous memory locations. One of their standout features is direct indexing, which allows you to access any element instantly using its index. For example, if you have an array storing 5 numbers, you can refer to the third number directly using the array name followed by the index in square brackets, like array bracket 2 bracket. This makes arrays extremely fast for retrieving or modifying elements. However, arrays come with some limitations. One key characteristic is that they are fixed in size. This means when you declare an array, you need to specify its size up front, like saying the array will hold exactly 10 elements. If your data grows beyond this size, you'll have to find other ways to handle it. Arrays are also relatively basic. They don't have built-in features for resizing, adding, or removing elements. Now let's move on to vectors, the more advanced and flexible cousin of arrays. Vectors are part of the standard template library, STL, in C++, designed to handle data that changes dynamically. Unlike arrays, vectors do not require you to define their size when you create them. You can start by emptying vector and add elements as needed, making them ideal for scenarios where the size of your data is unpredictable. One of the most important features of vectors is dynamic resizing. Behind the scenes, vectors manage memory automatically. When they run out of space, they allocate more memory and copy the existing elements over, ensuring you don't have to worry about managing this process yourself. This makes vectors incredibly flexible and user-friendly. Vectors also come with a range of built-in functions that make them a go-to choice for modern C++ programming. Let's talk about some of these key functions. One, we have pushback, which adds an element to the end of the vector, making it easy to grow your collection dynamically. 2 is popback, removes the last element, ideal for stacks like operations or cleaning up temporary data. Size returns the number of elements currently in the vector, saving you from manually tracking this yourself. Capacity tells you the total amount of memory allocated for the vector, which is often larger than the current size for efficient resizing. Insert allows you to add elements at specific locations, shifting existing ones as needed. Erase removes elements from specific positions or ranges, making it easy to modify your data. Clear empties the vector entirely, resetting it while retaining allocated memory. And shrink to fit reduces the capacity of a vector to match its current size, optimize memory usage. These built-in functions are what makes vectors so powerful compared to arrays. Instead of writing custom logic for adding, removing, or managing elements, you can rely on these functions to handle most of the heavy lifting. When to use vectors and arrays? Arrays are ideal when the size of your data is fixed, and you need high performance and low overhead. They are perfect for scenarios where memory usage needs to be tightly controlled, such as embedded systems or performance-critical applications. Vectors, on the other hand, are perfect for modern programming tasks where data size may change or additionally functionality like sorting, searching, and dynamic resizing is needed. They are versatile and much easier to work with for more applications. How to add them to your code. For arrays, you start by declaring the type of data you want to store, followed by the array name and the size in square brackets. This tells the program how much memory to allocate for the array and what type of data it will hold. For vectors, you include the appropriate STL header, then declare the vector with the type of data it will store and the vector name. You can start adding elements dynamically using built-in methods like pushback. To summarize, arrays and vectors are both a powerful tool in C++. Arrays offer simplicity and efficiency for fixed-size data, while vectors provide flexibility and a host of additional features for dynamic data. Understanding their key features and how to use them will help you write better, more efficient code. Now let's open up our programming compiler and see how they work. Alright guys, welcome back. What we're going to do is we're going to start off with our array example. We're going to go through 5 different steps. In step 1, we're going to declare an array. In step 2, we're going to get the input from the user. Step 3, we'll display the array elements we just got from the user. Step 4, we'll modify an array element that we just got from the user. And then step 5, we'll display the new modified array. Starting off in step 1, what we're going to do is we're going to create an array of type int called numbers, and we'll set the size of that array to 5. In step 2, we're going to want to get the values from the user that are going to be inputted into the array. So we'll start off with the cout statement, asking the user to enter 5 numbers into the array. Once we create that cout statement, what we'll do is we'll start off by creating a for loop. And what this for loop is going to help us do is it's going to iterate through the array for us so we can input and display the array. So we're going to set int I is equal to 0. Then what we'll do is I is less than 5. And what that's going to do is going to tell us how many times we're going to iterate through the array. So there's no reason to go 6, 7, 8, or 9 times because we only have 5 elements. And the I++ is going to help keep track of how many times we iterate through the for loop or the array. And what the ++ do is it increments I by 1. So because we're starting off with I is equal to 0, once we iterate through 1 time, I will now be equal to 1. Then I will then be equal to 2 if we iterate again, and then 3, and then so on. And once we get to I is like 6, there's no need for us to iterate through again. So then we know we're done iterating through the array. And inside the array, what we'll do is we'll create our cin statement so we can input the numbers inside of the array. Then moving on to step 3, it's kind of similar to step 2. We'll start off by creating a cout statement, and inside that cout statement we're going to talk about displaying elements inside the array. Once we do that, we're going to create our for loop again. It's going to be the exact same for loop. It's going to do the exact same function, but the inside of the for loop is going to be a little different. I++. Inside the for loop, instead of creating our cin statement, we're going to create another cout statement saying element is at index, boom. And then I recommend, of course, adding a space. It's going to help with readability, and we'll see that at the end of the video. Once I run the program, we'll do I, which I right there is going to be our index. And then once again, I'm going to create a comma here, space, comma, and space again. So we have spaces between our numbers, once again for readability. And then what we're going to do is we're going to print out our number that's at that respective index. And we're going to end that cout statement. And now we're done with step 3. In step 4, it's a little simpler than what we've been doing. There's no loops or anything, but it's also a little different. We're going to start off with another cout statement saying changing value at index 2. And what this is going to do, we're just going to change the value. So we're going to type out an array at index 2, which is 2 for our size, and then we're going to set that equal to 100. So say originally when we input our values and we put in the number 5 at index 2, once we get to step 4, what it's going to happen is it's going to change that number that we put at 2, so 5, and it will change it to 100. And the nice thing about this is step 5 is exactly the same as step 3. So all we have to do is copy and paste it. We'll just say we're going to create our cout statement displaying the element inside the array, then our for loop that goes through 5 times for each element that's inside the array. So then once we run the program, we'll see it's going to ask us to enter 5 numbers into the array. So we'll just do 1, 3, 5, 7, and 9. And as you can see, we're going to it's displaying the elements inside the array that we just entered, the user just entered. And then this is where that space comes in, where I talked about earlier in step 3. As you can see, it's much more easier to read the numbers here. If you didn't space them, it would be very conjoined together and hard to read. Then after we display, we can see we're changing the value at index 2, and then we're displaying the elements inside the array again. You can see at index 2, we're now displaying 100. And that's it for our array example. I'm going to cut the video, and we're going to go back and go through our vector example. Alright guys, let's get started with our vector example. Once again, we're going to go through it, the 5 different steps. The steps are going to be the exact same thing as the array example, and we're going to show the key differences of using vector to array when we're coding. So in step 1, we'll define the vector. Step 2, we'll get the input from the user. In step 3, we'll display the vector elements. Step 4, we'll modify an element in the vector, and in step 5, we'll display the new modified vector. Starting off, we can see that I've actually included the vector library, because once again, when you use vectors, you want to use the STL library so we can use some of those built-in functions that vectors provide. So starting off with step 1, what we're going to do is we're going to define our vector of type integer, and we're going to call it numbers. It's going to be a little different than arrays. We're going to start off by typing vector and then int and then the name numbers. So there you go. Now we have our vector of type integer called numbers. Then in step 2, it's going to be very similar to the arrays, but with some key differences. So we're going to ask the user to enter 5 numbers inside the vector. Once we do that, we'll create our for loop. Our for loop is going to be exactly the same that we used in the array example, because we're just going to be iterating through 5 numbers. So we'll create I is equal to 0, then I is less than 5, and I plus plus. Whoops. Once we do that, the inside of the for loop is going to be a little different. We're going to start off by creating a num of type int. This is where we're going to store our numbers initially. So then we create our cin statement num, because what we're going to do is we're going to add the numbers into using the vector built-in function, and we're going to use the pushback one. So that's going to allow us to add the number into the vector. So we're going to start off by using the vector name numbers, push underscore back, parenthesis, and then num, because that's where our numbers is stored. And what this is doing, once again, we're going to be adding our number into the vector using the pushback built-in function that vectors provide, instead of just directly adding it like we did into the array. In step 3, it's going to be pretty much the same thing as we did in the array. So we'll create our cout statement displaying elements inside the vector. Once we do that again, we'll create our for loop. Int I is equal to 0, I is less than 5, and I plus plus. Once we create our for loop, the inside is pretty much the exact same thing as we did with the array. So what we'll do is we'll create our cout statement again, because we're displaying element is at index. Once again, we want to add our space just so it's for readability for the user. We'll then do I for the index. Then once again, we'll create our comma for our numbers so we can separate the two, and then we'll call the we'll type out our numbers, which is our vector I, so we can get the actual number that is stored inside that index, and then we'll end our cout statement. In step 4, it's very similar once again to the array example. So we'll create our cout statement, changing value at index 2. Once again, we'll end it, and then what we'll do is we'll type out numbers again, and what this, once again, it's the same thing as the array. We'll change it at 2, and then we'll set it equal to, we'll change the number to 200 this time. Once again, step 3 and step 5 are the exact same thing, so we'll just copy and paste those over. Once again, you create your cout statement displaying the elements inside the vector, then you go through your for loop 5 times using the increment, then you'll just display the index, and then you display the numbers. Now when we run the program, you can see it asks us for the 5 numbers inside the vector that we want to enter. So once again, we'll just do 1, 3, 5, 7, and 9. Then it displays the elements, and we can see what the index is for each element. Then when we change the value at index 2, we can see it changes to 200. So I hope this video helps you guys understand the differences between array and vectors, and how you can use each to help each of your programs. I hope this helps make you guys a stronger C++ programmer, and tune in for more videos. Thank you.